Example 1.3 Equilibrium position. Two charged particles are placed as shown in the figure. Q1 equals 0.15 microcoulomb is located at the origin and Q2 equals 0.35 microcoulomb is located at the positive x-axis at x2 equals 0.40 meter. Where should a third charged particle Q3 be placed to be at an equilibrium point such that the forces on it sum to 0? I'll draw the picture. We have a coordinate system. Two charged particles are located on the positive x-axis. So this is a one-dimensional problem. We have two charged particles, two positively charged particles located on the positive x-axis. This is Q1 and this is Q2. Q1 is equal to 0.15 microcoulomb and Q2 is 0.35 microcoulomb. Both of them are positively charged. Q1 is located at the origin, so this point is 0. This point is 0. Its origin. And Q2 is located on the positive x-axis at x2 equals 0.4 meters. So this point is 0.42 meters. That means the distance from x1 to x2 is, this distance is x2, which is 0.42 minus 0, which is 0.42 meters. 0.42 meters. Yeah. The question is, if we have a third charged particle Q3, where should we place it so that there is no force, no net force acting on it? Or where is the equilibrium point? So that's the question. So I have a third charged particle, this one, let's say a negative charge. You can do the same thing with positive charge as well, doesn't matter. Anyways, so this is my third charged particle and negative charge. Okay, let's say I'm going to place this here on the right side. Okay, here. Yeah. So what will be the direction of forces? So this is Q3, right? It's a negative charge. Q3. There will be two forces. The first force will be from Q1 and the second force will be from Q2. I'll draw the forces. So this is Q1 being positively charged will try to pull Q3 towards its side. So direction of force by charge 1 on charge 3 is towards left, because Q1 is positively charged and Q3 is negatively charged. They are opposite, they're unlike charges, so they will attract. So Q1 will try to pull Q3 towards its side. Yes, so that's why the direction of the force is towards left. Now the second force is from charge 2, Q2, right? Q2 is also positively charged, so Q2 will try to pull Q3 towards its side. Okay, so again, force by charge 2 on charge 3 is also towards left. What does that mean? Because both of our forces are in the same direction, there's no way you could cancel it out, right? So Q3 can't be on the right side of Q2, right? Okay, so what's the next possibility? We can place Q3 on the left side of Q1. Let's see what happens. Okay, so we can't do this because the forces are in the same direction. So let's move Q3 to here, okay, left side of Q1 here. Okay, now again Q3 will be affected by forces from Q1 and Q2. Let's find out the direction of these forces. Okay, Q1 being positively charged will try to pull Q3 towards its side. So force by Q1, force by charge 1 on charge 3 is towards right. The next force will be from Q2. Q2 is positively charged, Q3 is negatively charged. So Q2 will try to pull Q3 towards its side. So this will be the direction of force by charge 2 on charge 3. Again, they are in the same direction, so you can't cancel it out, right? So there is no equilibrium point on the left side either. Yeah. One more thing, the question, they didn't mention the third charge is a negative charge, okay? But you can do the same thing with the positive charge as well. You'll end up with the same thing, same result, okay? If you place a positive charge here, Q1 will repel it, Q2 will repel it, so the forces are in the same direction, so equilibrium point is not on the left side. If you place the positive charge here on the right side, Q1 and Q2 will repel Q3, so again the forces are in the same direction. So our equilibrium point will be somewhere between Q1 and Q2. Okay, yeah, I'm going to place Q3 here, okay, somewhere here. Okay, we don't know where to place it. We are going to find this position. Let's say at this point, let's see if it works. Okay, Q1 being positively charged, Q1 being positively charged will try to pull Q3 towards its side. So this is the direction of F1 on 3, and Q2 being positively charged will try to pull negatively charged Q3 towards its side. Okay, so this is the direction of force by 2 on 3. Yeah, they're in the opposite direction. That means if F1 2 3, let's say F1 2 3 is positive 5 and F2 to 3 is negative 5, they will cancel out and the net force will be 0. So there is a chance, right? Okay, so that's why in my problem Q3 is in between Q1 and Q2. It can't be on the right side of Q2, it can't be on the left side of Q1 either. It should be in between Q1 and Q2. This is the reason for that. Yeah. Okay, now let's solve it. How to find this position of Q3? I'm going to delete all these things. Yeah. Okay, let's find this position. So this is x2. This origin is x1. This is x1, right? x1 is 0. Let's call this point x3. x3. So this distance, let's call it x3. Let me draw this. Yeah. Let's call it x3. We don't know x3. We are going to find x3. Let's find the position of Q3. That is at x3, right? Okay. So at x3, at x3, sum of the forces will be equal to 0. That's my statement. Okay, let's convert this into a mathematical equation. Sum of the forces. How many forces do we have here in this problem? We have 3 charges, okay, and we are finding the total force on Q3. Okay, we're finding the total force on Q3. So the total force on Q3 will be equal to force from charge number 1 on charge number 3, this one F1 to 3, and the force from charge number 2 on charge number 3. Okay, Q1 being positively charged will try to pull Q3 towards its side. That's why F1 to 3 is towards left. Q2 is again positively charged, so Q2 will try to pull Q3 towards its side. F2 to 3 is towards right. The idea here is if you add these two forces, you should get 0. Okay, yeah, so I'm going to write that here. F1 to 3 plus F2 to 3 is equal to 0. Now F2 to 3 is towards right and F1 to 3 is towards left. So I'm going to put a negative sign for F1 to 3 minus F1 to 3 equals F2 to 3. I'm taking this negative force to the right side. So F2 to 3 is equal to F1 to 3. Or you could say their absolute values are equal, right? Yeah. Okay, now we're going to write equations for F2 to 3, F1 to 3, then we'll solve for x3. What is the equation for force? Coulomb's force, or Coulomb's law. F equals K Q1 Q2 over R square. That's the general equation for Coulomb's law. Where K is a constant 9 times 10 to the power of 9 Newton meter square per Coulomb square. Yeah. Okay, so let's consider the first force, F2 to 3. F2 to 3. We have two charges. Okay, let's ignore Q1 for now. We have two charges, Q2 and Q3. The force F2 to 3 is equal to K. What are the two charges? Q2 and Q3. So K Q2, K Q3 divided by the distance between 2 and 3. Okay, so this is the distance between 2 and 3. I'll draw that. Yeah, blue color. Yeah. Okay, this is the distance between 2 and 3. So how do you, let's call it R2, 3, right? Yeah, R2, 3. How do you find R2, 3? R2, 3 is equal to, R2, 3 is equal to, this is R2, 3, right? So this distance is equal to the total distance, that is the distance from Q1 to Q2, this distance minus this distance, right? That is R2, 3. So R2, 3 is equal to the total distance from charge 1 to charge 2, that is x2 minus the distance from x1 to distance from Q1 to Q3, that is x3. So that is R2, 3. So R2, 3 equals x2 minus x3. I'm going to write it here. Yeah, let's write the general equation. K Q2 Q3 over R2, 3 square is equal to, now F1 to 3, this is the force by charge 1 on charge 3. So again we have two forces, charge 1 and charge 3, and the distance between them, let's call it R1, 3 squared. Okay, so K Q2 Q3 over what is R2, 3? Again R2, 3 is the total distance x2 minus this distance x3. So x2 minus x3, x2 minus x3 the whole squared is equal to K Q1 Q3 over, what's the distance between 1 and 3? Distance between 1 and 3 is x3, right? Distance between charge 1 and charge 3 is x3. x3 squared. Yeah. So we have K on the left side and K on the right side, so we can cancel it out. We have Q3 on the left side, Q3 on the right side, cancel it out. So our equation has been reduced to Q2 over x2 minus x3 the whole squared equals k is gone, right? Yeah. q1 over x3 squared. So our objective is to find x3. We have x3 here, x3 here. Let's solve this equation and find x3. Okay, so you can use your calculator if you want. If you're allowed to use calculator in the exam, you can use calculator, shift solve to find x3. Or you can use the proper method. Alright, so I'm going to take x2 minus x3 the whole square to the right side. I'm going to cross multiply it. Okay, cross multiply it. So it will be cross multiply q2 x3 squared equals q1 times x2 minus x3 the whole squared. I'm going to take x3 squared to the right side and q1 to the left side. So I'm going to divide with x3, divide with q1 as well. Okay, yeah. So q2 divided by q1 is equal to x2 minus x3 the whole squared divided by x3 squared. You can do this in one step. Just wanted to show you. Cross multiply and divide it. Okay, take x2 minus x3 the whole square to the right side, to the top, then q1 to the left, to the left denominator. Okay, you'll end up with the same equation. Okay, so we have square on the right side. I want to remove that square, so I'm going to take a square root on the right side. To remove the square, I'm taking this square root on the right side. Yeah, the problem is you can't do it just for one side. You should do it on the other side as well. Okay, so I'm taking the square root on the right side as well. Okay, yeah. All right, so left side will be root q2 over root q1. Right hand side will be, the square will be gone. Square root and square can be cancelled, so it will be x2 minus x3 over x3. Okay, I'm going to cross multiply this again. We need to find x3, right? x3 is on the right side. Now solve for x3. Our square is gone, so it's easy to solve now. Cross multiply it. x3 times root q2 equals root q1 times x2 minus x3. Again, we have an x3 here on the right side. We should take it to the left side, but before that we should open the bracket. So x3 root q2 equals x2 root q1 minus x3 root q1. Okay, now we need to find x3, right? So I'm going to take this x3 term to the right, to the left hand side. So x3 square root of q2 minus x3 root q1 will be plus. So x3 root q1 equals x2 root q1. Yeah, okay. We have x3 common in the left, x3 common here. Okay, let's take x3 outside the bracket. X3, if you take x3 outside, then you have square root of q2 plus square root of q1 on the left side. Right side, it's the same thing, x2 root of q1. Okay, now we need x3, so we don't want this thing on the left side, so I'm going to divide with square root of q2 plus q1. So x3 will be x2 square root of q1 over square root of q2 plus square root of q1, and that's our final equation. Now let's substitute all the values and find the answer. So x3 equals what is x2? X2 is 0.4, so 0.4 times square root of, what is Q1 0.15 microcoulomb. Micro you should convert to microcoulomb, you should convert to coulomb. So 0.15 micro is 10 to the power minus 6. 10 to the power minus 6 coulomb divided by square root of Q2. Q2 is 0.35 microcoulomb. 0.35 0.35 0.35 microcoulomb. Micro again, if you convert it, you will get 10 to the power minus 6 plus Q1 is 0.15 times 10 to the power minus 6. So the answer is 0.158 meters. Or if you convert this to centimeters, multiply with 100, you get 15.8 centimeters.